Hello, ladies and gentlemen. This is Miss Stratton. And what we're going to be looking at today is um, how to spot bad science. We've all been online and seen articles that we thought were either too good to be true or just looked ridiculous, or maybe even something that we agreed with that may not have actually been good science. So, we're going to look at a couple different ways, actually 10 different ways, to determine whether we're looking at good science or bad science while we are online. So, the very first thing we are going to look at is why did you click? So, what made you click on the story or the picture? Are you hoping it's true? Does it agree with what you already think? If it does, if it's something you read just because you think it's going to agree with you, this is called confirmation bias. And so we are more likely to click on something that is going to be something we agree with. So make sure that you're not just looking at things through your own filter, but make sure you're looking at things based on what's actually true. So if we are looking at this right here, this is sort of a classic clickbait kind of thing. It says, "This outrageous truth about gummy bears will destroy your world." Um, it's probably not going to really destroy your world, but I mean, we've all eaten gummy bears. Most of us like gummy bears. So honestly, I would be kind of inclined to click on this because I would want to know what's so special about green gummy bears. It's probably not going to be green science or green science, good science, because it's making us click just because it's something that conveys a strong emotion. So the second thing we're going to look at is, why is it showing up in your feed? One of the things you want to do is look where the post came from. You want to make sure it's from an actual scientific organization, maybe an educational institution, something like that. Make sure you're not going to see the words promoted or sponsored. That means somebody is paying for you to see that. So let's look at this article right here. So it says, "An unbelievable scam of cancer industry is blown wide open." So we look on here and we don't, it doesn't really tell us a lot about this organic family. It We don't see anything about the company, but what we do see is advertising. If one of their big things is advertising, that their main goal is money, not really just spreading good science. So if you see lots of things about advertising, lots of advertising down the side, that's probably a pretty good tip that you're not looking at great science. So number 3 says, what does the domain name or URL tell you? So if you see something that's like, you know, cancerousgarbage.com, it's probably not going to be a great scientific website. So we're going to look at things that end with .edu or .com. For example, if we find something from tntech.edu, so this is an article about how important teacher mentors are for students. So, and if we look, we know this is from a reliable resource because it's from a college, actually the college in our town. So let's keep going. So number 4, what does the headline look like? Does it use words like shocking, revealed, proves? We've all clicked on things like that because you want to know what's so shocking. But that's typically a pretty good clue that what you're looking at is just for shock value and not for real scientific information. So let's look at a couple of examples here. So again, I'm going to pick on this unbelievable. Like we said earlier, their big focus on advertising, it doesn't tell us about the website. And if they're scared to tell you about themselves, there is probably a reason. So this article right here is called "Finding Living Martians Just Got a Bit More Believable." That doesn't necessarily sound like it comes from a super reliable resource. However, this is sciencenewsforstudents.org. It's not a .com or anything like that. If you go over to the menu, they have an about section. They're willing to tell us about themselves, which is pretty important. Now, so we found our about link. Which is good, which tells us that, they're being transparent. They want us to know what their mission is. All right, number 6. So if we go up here, this is actually a Twitter a Twitter post or a tweet. Um, it's talking about this angry mob that is reportedly heading to Washington, D.C., and it shows you what's supposedly 15,000 bikers. Um, However, what we find out is this is a Sturgis rally, and Sturgis is a really, really big motorcycle rally that happens in South Dakota every year, and not even at the right time of year for this tweet to have been sent out. So we know this is not a good resource, and there's no one is attributed to this video or whatever. On the other hand, if we look back at our Finding Living Martians, we see this image right here. It tells us where it's taken. It's taken near Mars' South Pole. The image was taken from the European Space Agency's spacecraft. And if you go down to the bottom, there's even a link to the photographer. So the more information they're willing to give, the more likely it is that you're looking at a good scientific article. Now, what if an unusual claim is made? We're all, excited to see things that are unusual or different or kind of crazy. And sometimes those are legitimate, but a lot of times they aren't. So let's come over here and look at this Facebook post. According to this, we discovered that the Earth's crust was moving, and no one has ever seen the crust move before. However, we look and we see that what we're really looking at is landslides, which is technically the Earth's crust moving, but not the way they're making it sound like. And furthermore, the video on the bottom wasn't taken in Mongolia, it was taken in Italy. So this is not going to be good scientific information. I mean, it's just some random guy on Facebook too. So, all right, number 8 are facts and data shown. So, if we're not seeing actual numbers, if we're not seeing charts and graphs and things like that, there's a really good chance that this is garbage science, that it's not legitimate. It says if you see language like may result or has an effect up to, these are really vague and probably not based on any actual research. So this article right here is talking about how eating an egg and banana can cause death. I'm not going to make you read all this, but according to the article, this combination causes poison in the stomach that is fatal. It's formed only in human stomachs when this combination of egg and banana reacts with acid, and it creates a harmful chemical. It doesn't tell us how much egg and banana. It doesn't tell us what chemical is created. It doesn't tell us how it affects us. So there's no real data given, just very general very general information. And if you've ever eaten banana bread, you already know that this isn't true because egg and banana are both in banana bread. So, number 9, is the language precise? Good science is described with very, very careful language. It's not going to use name calling, and it's not going to exaggerate. It's not going to try and get an emotional response. So saying new data destroyed previous ideas, no real scientist is going to say that. They're going to say their results are different. They're going to say that their evidence raises questions. They're never going to say that new data destroys old science. That's just not how real scientists speak. So again, if we look at our unbelievable cancer scam, we're going to see, that really inflated language. The cancer industry is blown wide open. The fake diagnoses, the shocking admission. And then it goes down here to talk about how all cancer doctors are quacks and things like that. Scientists don't use that kind of language. They just don't. They use things that are based on factual information. And last but not least, are there links to other studies? And these can be links that agree with the article, or these can be links that don't agree with the article. In fact, if you are looking at links that don't agree with your article, that's an even bigger case for this being good science. Good scientists look at both sides of the information. So let's look at another example of that. So that unbelievable cancer scam, there's no author attributed to it. There are no no citations. In fact, there's just other links to other clickbait articles down at the bottom. If we go back to our Tennessee Tech article, we see that here at the bottom, it will let you find more about the Calder findings, which is what this article was based on. And we see that we have, it's a .org. There's a paper here that no doubt is littered with citations and is going to be attributing their information to actual data. So hopefully these 10 points help you to remember how to discern good science and bad science. And as always, you'll have this in your folder to look back on as we do lots and lots of research throughout the year. All right. Hope you learned something today. Bye.